Hi everyone, I think this is going to be the first video I've made for you. Hope it's not too often, but raising kids, sometimes doctor things happen. Hope you will stay healthy and hope you will stay safe, and I'll wish you a long weekend. Sorry I can't be with you, but I do have a video. It's a part 2. Today's lesson is going to be 2.6, solving inequalities algebraically. Now, I'm going to go straight into it, but first, just letting you know, today there's going to be a lot of handouts. It's going to be a practice question sheet on 2.6. There is a chapter 2 test, the assignment thing, where you have 3 T questions and you're going to get one of them on the Wednesday, as well as a Unit 2 chapter test review. I'm supposed to give it to you on Monday, but since it's a long weekend, some of you might want a head start. I'm going to give it to you at a time. Okay? Please don't leave without getting a practice question sheet for 2.6, a chapter 2 assignment question thing with 3 questions on it, as well as a chapter 2 test review page. Whew, that's a lot. Let's get to it. Solving inequalities algebraically. So today, the whole point is, what if you don't have a graph? Okay, what if I don't give you a graph like the ones we did yesterday? That's okay. The whole point is to try and not use a graph. Okay. Oh, that's a lie. Sometimes, because you are so good with chapter 1 and being able to sketch using factored form, you should be able to graph very quickly and tell me where the inequalities are, right? But today, I'm actually going to try to implement an interval chart or a testing cases method to help solve inequalities too. I'm still going to graph it, but I want to use the graph to show you that the interval chart and the testing case method works just as well. Why am I doing that? The interval and chart method, or even the testing cases, is going to be something that you will do in chapter 3 as well as in calculus. So I thought, why not introduce it early and sort of get you used to it so chapter 3 is not overwhelming. Okay, so the idea of interval chart and testing case methods for this question is this. When you're doing inequalities, you're saying, hey, when is this equation less than or equal to 0? That's like another way of saying, hey, when is the y value going to be less than or equal to 0? That's another way of saying, hey, when is the y value a negative number versus when it's a positive number? Why is that important? Well, if you think about a parabola, let's pretend here's a y-intercept, x-intercept, here's an x-intercept, and here's a parabola. When is this parabola positive? Well, we talked about yesterday how this is when it's a positive, all the x values bigger than that point, and when the x values are smaller than that point is when the y values are positive. In the contrary, all the x values between these two x-intercepts are what makes the y values negative, right? So you can graph it and make do with what we did yesterday, or we can do this chart, which helps us distinguish when I get a positive y value and when I get a negative value, and that involves the x-intercepts. Okay, so let's get to it. I am going to go straight into this and say, okay, solve. When is this equal to or less than a 0? Just as before, factor for the x-intercepts. We're going to sketch using the degree and end behavior, and we can start talking about it. Once we complete that, I will show you an interval chart. Let's do it. I see that -2, -6, -12, blah, 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 they are all multiples of a2. So I am going to factor that -2 out. And away we go. I see this is going to be integral 0 theorem, looking at the -8 to help me find a factor. I will test. Looking at this, a 1 will not work. A -1 might. Oh, that's a square, by the way, my bad. I think a -1 might. So I'm going to try it. Test when x equals a -1. That means x cubed plus 3 times x squared minus 6 times an x minus an 8, negative 1, positive 3, positive. Yep, that works. Yay. So let's do it. I'm going to go straight into factoring because I am very interested in the x-intercepts. We've got 1, 3, negative 6, negative 8, and a negative 1, 1, negative 1, 2, negative 2, negative 8, 8, 0. Great. That means I'm going to continue writing down here, negative 2. The bracket will have x minus 1 followed by x squared plus 2x minus 8 and no remainder. And that is less than or equal to 0. I will continue factoring. So we have x minus 1, x plus 4, x minus 2 is less than or equal to 0. And here's what would be the typical answer or typical solution. We have an x-intercept at negative. Sorry, that's a plus 1. Plus 1. X-intercept at negative 1. 2, 3, 4. X-intercept at negative 4, right? Because negative 1, that should be x plus 1, sorry. And an x-intercept at 2. So negative 1, not positive 1. Negative 4 and 2, because that is x plus 1. Sorry about that. And I'm going to cheat a little further just to help me graph. My y-intercept is 16. And leading coefficient is negative, so it's probably going to look something like that. So judging from this, when is this graph less than 0? It's right here. I can write in the interval negative 4 to negative 1, my function is a negative value, a negative y value, under 0. And for any x value 2 or greater, my curve is going to be, my y value is going to be under 0. It's going to be a negative. So the answer would be, okay, the function is less than or equal to 0 in the interval. And just because we've been practicing or just using it here and there, I'm going to continue. Interval from negative 4 to a negative 1 and 2 and above. So I'm going to say union. That's a little u for union. From 2 to infinity. Okay. Now, I'm making this video ahead of time, which means I actually don't know or don't remember if I covered this in 2.6 part 1. And so if I didn't, just bear with me. Don't worry too much about notation. This is literally what I mean, negative 4 to negative 1 and then 2 up to infinity. You might wonder why there is a difference between square brackets and curve brackets. I will explain if I have not done so in 2.6 part 1. Okay, now this, I am actually going to compare that with this new method called a chart method. A chart method will take your x-intercepts, literally this section, and turn it into a chart. The testing cases method is sort of like a number line method where instead of drawing the entire thing, I simply use this line to demonstrate whether it's above or below. So this is actually something I think Ms. Malloy, another math teacher at Northern, likes to do more. She draws a number line. So this is like a testing cases method or the number line method. And you might like this, okay? And she will place all x-intercepts and vertical asymptotes. You remember vertical asymptotes from grade 11, okay? Place all x-ints and vertical asymptotes. Sorry, let me move that over. Okay. But of course, we haven't run into any vertical asymptotes. You're going to see more of that in chapter 3, so don't worry. So I'm going to put a -4. I'm going to put a -1. I'm going to put a 2 there. It doesn't matter what the space is because you'll see. Between each number, we're going to choose any random we want and test it inside the equation. So let's do an easy one. Let's do a number that's bigger than 2, like a huge number, like 1 million. Okay? If we are at x equals 1 million, what do you expect the y value to be? I hope you said it's going to be a negative number. All right? So -2, -2, a million plus 1, that's going to be a positive number. A million plus 4, that's going to be a positive number. A million minus 2, that's a drop in the bucket. That's still going to be a positive number. If these three brackets multiply with the -2, what would be the overall value? It's going to be some negative number, isn't it? Ta-da! Underneath the y-axis, it's going to be a negative number. Choose a number between -1 and 2. I think we can all agree the easiest number is a 0. So if I choose a 0, a -2 will multiply with 0 plus 1, that's a positive number. 0 plus 4, that's a positive number. And 0 minus 2, that's a negative number. What is -2 times positive, positive, negative? It's going to be a positive number, which we expected. So all the numbers between -1 and 2 are going to be positive. Next, choose an easy number between -4 and -1. I will choose -2. So -2 multiplied by, I'm going to do down here, -2 multiplied by -2 plus 1, that's a negative value. -2 plus 4, positive value. And -2 minus 2, negative value. Multiply all that, I would have a negative value, which we expected. The y values between -4 and -1 are negative. Then lastly, over here, what is a big negative number? Let's do -1 million. -2 times a huge negative number times a huge negative number times a huge negative number. My overall is going to be positive, which we expected. So you see, you could draw the graph using leading coefficients and degree. You can also go straight into a number line and test numbers. Or one last method. This is my personal way of doing it because it overlaps and is very similar to how you would do a certain something in calculus. And so again, I teach my kids ahead of time. Just like before, you are going to place all x-intercepts and vertical asymptotes, but instead of a number line, I do it as a t-chart. So place all x-int and vertical asymptotes. So it would be -4, -1, and a 2. And instead of a number line where you do all the brackets as is, I actually take every possible factor or value that could change signs, and I place it all in one location. And then I finish with the overall function. So -2, x plus 1 was one of the factors, x plus 4 was one of the factors, x minus 2 is one of the factors, -2 is one of the factors, and so I place all the factors on the left. And now I do what I did in the number line. I choose a number. Let's go right to left again. I choose a number bigger than 2. Let's choose 1 million. Even if x is 1 million, the -2 is a negative, so I'm going to do that. If x is 1 million, the bracket turns into a positive number. A million plus 4 is still a positive number. A million minus 2 is still a positive number. So when all of that is multiplied, negative times positive times positive times positive, I have a negative function. The 2 gives me a x-intercept, so I'm going to write a 0. A number between -1 and 0, 0, right? Well, even if x is a 0, -2 will always be -2. X plus 1 is positive, so 0 plus 1 is positive. 0 plus 4 is positive. 0 minus 2 is negative. So when a negative times positive, the function will be positive. -1 is an x-intercept, so it gives me a y value of 0. A number between -4 and -1, I'm going to just quicken the pace here. That's a negative, positive, negative, multiply all together, that's a negative. X-intercept of 0, and a huge negative number like -1 million. It's a negative, negative, negative. The function is a positive. And that, once again, matches with my number line. Positive, positive. Between -4 and -1, there were negatives. Between -1 and 2, it's positive. And 2 and above is a negative value. They all agree. How about I write the negative as a different color, just so you know what I'm talking about. Okay, they all agree. So whatever method you like, go for it. All right. That's essentially the end of the lesson, and I would stop it here, but I'm going to ask the substitute teacher to pause the video and move on to the next question after I explain it. Okay. So let's try this one more time. Here's another question where it's asking you to use interval chart or whatever because it's going to be a little annoying to graph, or the graph is not as x-intercepts. Let's try to understand this question. Solve when this function, the 4x cubed function, is going to be less than or equal to this 1x cubed function. Another way of saying is, when is the y value of this function going to be smaller than the y value of that function? Another way to interpret that is, when is the 4x cubed function going to be under the x cubed function? So based on this picture, I would say, when x equals -2, the y values are the same. But if the x values are lower than -2, my 4x cubed is absolutely underneath the other curve. So I am interested in when the x value is left of -2. But if I move to the right of -2, the 4x cubed function goes above. It is not less than the 1x cubed function. And so I am not interested in this area, but at this point it crosses over again. Here, the 4x cubed function is here and it's underneath the other. And then somewhere here, it crosses over. That is the 4x cubed function. And the bottom one is the x cubed plus something function, right? So based off of this, I see 1, 2, 3 locations of interest that might determine my interval. Okay. Yeah, and I see that I didn't actually write the interval answer for these two, but I'll do it for the next one. Okay. So of course, we don't want to solve this. This is really annoying, and it might require more techniques. And so why not modify or manipulate this so that we can answer it? What do I mean by that? Turn this function into a single curve where the other side equals a 0. Just like this. One side was equal to 0, so we were able to use our factoring skills, making the equation equal to a 0. Here, nothing equals a 0. So let's change it so that we can make it a 0. Okay, I'm going to get us started. So I'm going to bring everything minus x cubed. This is 3x cubed. minus 7x squared minus 7x squared. This becomes negative 5x squared. No x, so just negative 16x. Minus 5 minus 5. This becomes positive 12. And there's our new equation. Given this, I'm going to ask you to try. Whether you want to graph 1, use a number line 2, or use an interval chart 3, stick to 1 and try this. I'm going to ask the substitute teacher to pause for maybe 10 minutes, and then replay the video once again when you feel everyone is ready. Okay, at this point, I'm going to assume that the class did pause to try it on their own, and then we're back here. 3, 5, 16, 12, no, they are not multiples of 3, so it looks like I'm going to have to test by rational zero theorem. 1 does not seem to work. A negative 1 does not seem to work. Shall we try a 2? A 2 does not seem to work. Oh, maybe. Okay, let's test. I'm going to test a 2. 3 times 2, 4, 8. Minus 5 times 2, 4. Minus 6 times a 2 and a 12. 24. Minus 20. Minus 32. It does not work. Okay. How about a negative 2? Negative 8 minus 5 times a 4 plus a 32 plus 12. So this becomes negative 24, negative 20 plus 44. Perfect. That equals a 0. So x equals negative 2 works. I'm going to go straight into it. Synthetic it out. We've got negative 2 with coefficients 3, negative 5, negative 16, 12. We've got 3, negative 6, negative 11, 22, and 6. Negative 12, 0. Perfect. Once again, rational 0 did not fail me. So now we have x plus 2 left with 3x squared minus 11x plus 6 is less than or equal to a 0. So x plus 2, that must be 3x, and that must be an x. 6, got to get as big as negative 11. Looks like it's a negative 3 with a negative 2. So from here, if you decided to do a graph, you should look something like negative 2, 2 over 3, somewhere here, and 3, positive a value, and a y-intercept of 12. It's going to be something like this, which allows you to choose your interval charts. It is negative when x is going to be negative infinity to a negative 2 include union 2 over 3 comma a 3. If you chose the number line and pretend I don't have a graph for you, you would have still written negative 2, 2 over 3, and 3 in chronological order, obviously. And we will test numbers to plug into the factors here. We've got positive infinity, which means it's going to be a positive times a positive times a positive. It's going to be plus. And I'm going to guess it's a negative, right? A number between these two, the easiest number would be a 1. So 1 plus 2 is a positive. 3 minus 2 is a positive. 1 minus 3 is a negative. It's going to be a negative curve. Number between 0 is the easiest. Positive, negative, negative. That's a positive. A negative 1 million would give me a negative times a negative times a negative. It would be negative. So using this, the left function would be less than the right function when this is less than a 0, which means x belongs to negative infinity, comma, negative 2 square bracket, union, square bracket, 2 over 3, comma, 3. Same answers. And of course, if you went by my style, same idea, it would have been negative 2, 2 over 3, a 3. There's no vertical asymptotes, that's fine. The 3 brackets I'm using are x plus 2, 3x minus 2, and x minus 3. And that will let me multiply for my function. Huge, gigantic number, positive, positive, positive. That becomes a positive. The 3 is an x-intercept. Between here, positive, positive, negative, I would have a negative x-intercept. Positive, negative, negative, I would have a positive x-intercept. Negative, 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 that is a negative. So where am I looking for? I'm looking for when the function is less than a 0 or equal to a 0. And I will get the same intervals. X belongs to negative infinity to negative 2, union, 2 over 3, comma, a 3. So once again, this answer right here is not when is it less than a 0. We go back to the original question and says, hey, that left equation is smaller than the right equation when the x values are way left of negative 2 or between 2/3 and 3. Does that match my graph above? Let's see. When the x value is negative 2 or lower, this curve is underneath the other. And when the curve is between 2 over 3 and 3, the curve is underneath the other. Perfect. So it gets exactly what we were thinking, or what we were seeing up here. And we were able to even identify this slightly ambiguous point between integers. I hope you get it. If not, you have quite a bit of time to practice. Do you have to resolve to this? Not really. But there will come a time where we say, don't even sketch it, just tell me what the intervals are. And sketching it will essentially be a waste of it. Like there's no reason to go about all of this. Just go straight into a number line or interval chart. There will be times. I know it's a little bit weird and you would never imagine why, but there can be times where it's just more efficient to go one or the other this way. So I would hope that you be able to do this, obviously, but also be able to do one of these for our immediate future. Whatever is comfortable. Okay? Hope that's good. There are some practice questions you can do here. There's also the sheet that I mentioned. There is a chapter 2 assignment 3-question problem set that you got to practice for an evaluation. And you have a chapter 2 test review also to pick up. Suffer well. Have a great long weekend. And we will see you after the week. Have a good one.